This is a typical differentiation question, and the first part of it requires us to find the coordinates of the stationary points on the curve f of x equals 1/3 x cubed minus x squared minus 3x plus 11, and then we must determine the nature of these points. So to answer the first part of the question, determining the coordinates of the stationary points on a curve, we are required to obtain the gradient function of that curve, which means that we need to take the first derivative of f of x, which is f prime x, and we need to set that equal to 0 in order to find the stationary points. We then solve for x and find the corresponding values of y to obtain both the x and y coordinates of those points. So for this particular question, f prime x, that's our first derivative, is equal to, so we must differentiate 1/3 x cubed minus x squared minus 3x plus 11 with respect to x. So 1/3 x cubed, that will be 3 times 1/3 is 1, x to the 3 minus 1, so that's going to be x squared, minus x squared, so that will be minus 2x when we differentiate, and then minus 3x, the derivative is minus 3. Of course, the derivative of a constant is equal to 0. So our first derivative function is x squared minus 2x minus 3, and we must set that equal to 0 for stationary points. And it is important for us to write this down as part of our working. So we are justifying here why we are setting the first derivative equal to 0. The reason we are doing that is in order to find the stationary points. X squared minus 2x minus 3 will factor as follows. That will be x minus 3 by x plus 1 equal to 0, and therefore x is equal to 3 in the first case. If x minus 3 equals 0, then x is equal to 3, and if x plus 1 equals 0, then x is equal to minus 1. So the x coordinates of the stationary points are 3 or minus 1. Of course, we must now find the y coordinates. So when x equals 3, f of x equals, so we substitute 3 into 1/3 x cubed minus x squared minus 3 by x plus 11. That is equal to 3 cubed is 27 by 1/3 is 9 minus 3 squared is 9 minus 9 plus 11, so that is 9 minus 9 is 0, minus 9 plus 11 is 2. So that point is the point 3, 2. When x is equal to minus 1, f of x will be equal to 1/3 of minus 1 cubed minus minus 1 squared minus 3 by minus 1 plus 11, and that's equal to minus 1 cubed is minus 1, so this will be minus 1/3 minus 1 plus 3 plus 11, and that's equal to 14 minus 1 is 13 minus a third is 12, and 2/3 Therefore, the stationary points are, and notice that this is a cubic equation. The curve is cubic because it's 1/3 x cubed minus x squared minus 3x plus 11. So the degree of this curve is 3. When we differentiate a cubic curve, we will obtain a quadratic. That's useful to know. So usually when we solve a quadratic equal to 0, we would get 2 solutions. So we expect to get 2 stationary points, as indeed was the case here. The first one, when x is 3, f of x is 2, so that's the point 3, 2. And the second stationary point, when x was minus 1, y was 12 and 2/3. So those are our 2 stationary points. That brings us to the end of the first part of the question. Now we need to determine the nature of these points. Therefore, we need to carry out a second derivative test. What is the second derivative test? Well, we already have the first derivative function. It was x squared minus 2x minus 3. We now need to differentiate that to obtain the second derivative function. And then we will substitute the x coordinates of our stationary points. And if that leads to a second derivative which is greater than 0, then the point is a minimum point. And if the second derivative gives us a value that's less than 0, that is a negative value, then the stationary point is our maximum point. So f double prime x, that's our second derivative. To obtain that, we need to differentiate the first derivative. That's x squared minus 2x minus 3, which gives us 2x minus 2 being our second derivative function. So this will be 2x minus 2. Now, our first stationary point was the point 3, 2. Notice that f double prime x is a function only in x, 2x minus 2. So we are only interested in the x coordinate. In order to evaluate the second derivative, we only need the x coordinate of the stationary point. When x is equal to 3, f double prime x is equal to, so we substitute 3 for x in our second derivative function. So that will be 2 times 3 minus 2, which is equal to 6 minus 2, which is equal to 4, and that is greater than 0. That is important. It's positive, and therefore, since the second derivative function is positive when x is equal to 3, that means the point 3, 2 is a minimum point. It's a minimum point because the second derivative function is greater than 0 when x is equal to 3. Great. Now for our second point, when x is equal to minus 1, f double prime x is equal to, again, 2x minus 2, so that's 2 times minus 1 minus 2, which is minus 2 minus 2, which is minus 4, and that is less than 0. It is negative. Therefore, minus 1, 12 and 2/3 is a maximum point. It's a maximum point. So again, to summarize, we first find the first derivative function. We set it equal to 0 for stationary points, and we solve for x. After solving for x, we substitute into f of x to obtain the corresponding y. That enables us to answer the first part of the question and find the stationary points. At this point, to determine the nature, that is whether the point is a minimum or maximum, we obtain the second derivative function by differentiating the first derivative function and substituting the x coordinates of our stationary points. If the second derivative value is greater than 0, then the point was a minimum point, and if the second derivative value was less than 0, then that means that the stationary point was a maximum point.